Hi, chemistry students. Today I would like to share with you some tips on how to balance chemical reactions when you don't have the benefit of the simulation to illustrate the particles for you. So as a reminder, the whole purpose of why we balance chemical reactions in the first place is that every chemical reaction has to follow the law of conservation of mass. Atoms don't just appear or disappear, they just rearrange how they're bonded. So the way we balance chemical equations is by writing coefficients in front of some of the formulas. We are never allowed to change a subscript. If we change the subscript, then this wouldn't be water anymore. So we can, however, double the amount of water or triple it or whatever. So some tips, things to remember. Probably the biggest change when you do this on paper, you have to do a bit more of the mental work yourself. Instead of picturing the particles, you're going to be multiplying some simple numbers in your head. So remember, whatever coefficient you put in front multiplies everything after it. And the other key tip is to balance one element at a time. So when you look at an example like this, we have a chemical equation where we have hydrogen bromide breaking down, decomposing into its elements, turning into hydrogen and bromine. But if we pick an element, we can see, for example, hydrogen is not balanced. We start on the reactant side with one hydrogen, and we end with two hydrogens. That's not balanced. Also, we start with one bromine, and we end with two bromines. That's not balanced either. So, in order to get this to balance, we need to write a coefficient. And since I have to end with at least two hydrogens, remember this subscript can't change. If I end with two on the product side, then I have to start with two hydrogens on the reactant side. So I would just write a little 2 here in the front. Now this 2 multiplies everything after it. So I have 2 hydrogens on the left side of the reaction, and I have 2 hydrogens on the right. That's great. But this 2 also multiplies times the bromine. I have 2 bromines on the reactant side, and I also have 2 bromines on the product side. So this is balanced. Now, technically, we could put coefficients of 1 and 1 here, like on the computer. But chemists are lazy. Chemists tend not to do that. It's like in math class. If you just have something like x squared, you don't say 1x squared, you just say x squared. So this is balanced. It follows the law. We're done. Another example, what if we wanted to do the synthesis of water, combining hydrogen and oxygen to make water? Same process. We look, I see I have 2 hydrogens on the reactant side, 2 hydrogens on the product side. Remember, this arrow separates reactants on one side, products on the other. But I start with 2 oxygens and I end with only 1 oxygen. So that's not balanced. So to get that to balance, I need a number that I can put in front, that when I multiply it would give me 2 oxygens. And we can't see it, but there's an invisible 1 here. So I need, what number times 1 would give me 2? Pretty straightforward. I just put a 2 here. Now, this 2 multiplies times the 1 oxygen to make 2 oxygens, which balances that out. But it also multiplies times the 2 hydrogens. So 2 times 2 hydrogens is 4 hydrogens altogether. And I need to get those to balance too. So if I have 4 hydrogens on the product side, to make it so I have 4 hydrogens on the reactant side, I need a number that when I multiply times 2 gives me 4. It's a 2. So far, so good, so easy. Both elements are balanced. This reaction is balanced. A couple last ones that are a bit trickier. You look at this reaction, phosphorus is balanced. There's 1 phosphorus on each side. We have 2 chlorines on the left and 3 chlorines on the right. That's not balanced, and unfortunately 2 and 3 don't go nicely together. So the tip for when you have 2 numbers, especially 2 and 3, that don't go nicely together is to find a common multiple that they can both go into. So a common multiple of both 2 and 3 is 6. So if we can make it so we have 6 on each side, we know that that will balance. So if I wanted to make it so I had 6 chlorines on the left side, the number I put in front, what multiplies times 2 to get 6 is 3. Nice little trackpad number writing. And then on the right-hand side, to have 6 chlorines, what times 3 gives me 6? I need a 2 here. So now I have my chlorines balanced. 3 times 2 is 6 chlorines. 2 times 3 is 6 chlorines. But remember, this 2 also multiplies times everything, including this phosphorus. So the phosphorus used to be balanced, but by putting this 2 here, it's not balanced anymore. And now I need to go back and fix that. If I have 2 phosphorus on the product side, then I need to make sure that I have 2 over here on the reactant side. And I'll put a 2 here. All right, last example. What about when you have polyatomic ions? So when you see parentheses in a formula, like down here, what does that mean? If you remember from a previous lesson, it means that you have parentheses represent groups of atoms that stayed together in a chemical reaction. They're basically the polyatomic ions from table E. So this AlOH3 means that you have an Al with, sorry, it means you have an Al with 3 groups of OH connected to it. And I will do a poor job of arranging it. So AlOH3, this formula down here means you have an Al and 3 groups of OH connected to it. So there's 1 group, 2 groups, 3 groups. So that 3 distributes to everything on the inside, meaning you have 3 O's and 3 H's. But I don't want you to think of it individually as O and H. I want you to think of it as a group of OH's. So when I want to balance this equation, I'm going to balance my polyatomic ions first, my parentheses first. So when I look at this and I see on the left-hand side, I have 3 groups of OH on my reactant side. I go over on the product side, I only see 1 group. So to make it so I have 3, I would put a 3 in the front right here. 3 groups of OH on the left side, 3 groups of OH on the right side. Now I would move on to the next element. I would probably notice by putting this 3 here, I have 3 NAs on the product side. So I would go back to my reactant side and put a 3 here to make sure that I have 3 NAs as well. Then I would check another element. Let's see, by putting a 3 here, I made it so I have 3 Brs. Let me go to my product side. Oh, there's already 3 Brs. Great, that's balanced. What else do I need to check? What about aluminum? 1 aluminum here, 1 aluminum here. I think I just balanced everything. And that's the thought process that you follow. Take it 1 element at a time until everything is balanced. And just remember, whatever coefficient you put here multiplies times everything. I hope this was helpful, and good luck.